Welcome everybody. Today we're going to talk about the organic chemistry. This course with the organic chemistry is going to be two parts. The first part I'm going to deliver it today. This has basic fundamental knowledge about the organic chemistry, but further on after this two series I'm going to upload more sophisticated and more complex things about the organic chemistry. So let's move into the other slide. So what is organic chemistry? Organic chemistry is systematic study of compounds of carbon. Systematic study of compounds of carbon. So you can see study of compound of carbon. So what are organic compounds? What are organic compounds? Are class of chemicals compounds that occur naturally, but also it will be synthesized in laboratories too. So you can read these things while holding your video, but let's move into the problems and things more important. So this is uh, the 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 simplest hydrocarbon is methane. It has one carbon. This is a big ball represent the carbon. This one over here is carbon, and a small four. This is balls represent hydrogen. So therefore this is the structural formula. So ethene is the smallest alkene, and ethine is the smallest alkyne. So you can see what the basic is. Everything has carbon and hydrogen. The bonds are the different things only. So classification of hydrocarbons. So hydrocarbon classification is very easy. We don't do much further. So normally there are two kind of hydrocarbons. One is aliphatic, other one is cyclic. Aliphatic means always straight chain. Cyclic means they are cycle. So both of them, cyclic, aliphatic, they divided into saturated and unsaturated. In aliphatic, saturated means alkanes, unsaturated means alkene and alkyne. And cyclic, saturated means, for example, cyclohexane, unsaturated, for example, benzene. So here alkane, so you can see alkene and alkyne are unsaturated. That means they have double bond and they have triple bond. Triple bond for alkyne, double bond for alkene. So alkane got only single bonds in between carbon. Therefore they call alkane. And if you go cyclohexane, they also cyclo, and benzene also like circular thing. So we're going to talk about this everything in this course, and it's not much greater detail, but with the fundamental things you have this one enough for you. Okay. So this is the Lewis structure. This is the Lewis structure of methane. So you can see like what's happening over here. So for example, CH4 over here. So when you deal with the Lewis structure, you know this CH has covalent bond, so they keep common two electrons to make one bond. So one, for example, the cross given by the cross electron given by the carbon, and hydrogen given the dot. So dot cross dot cross dot cross, and ultimately this all should be 8, 2, 4, 6, 8, and hydrogen satisfied with 2, all 2 of them here. Therefore that's how we write the Lewis structure. So uh, Lewis structure, then structural formula is this one over here. It's also easy one. It's just representing one this paired electron as a one bond. So therefore one bond in everywhere over here. Sorry, H. So this is the actual space representation of methane. It has 195 to 109.5 degree of angle between this plane. This is a good thing to know. This is the ballistic model. This is how we represent methane molecule. We move to the other side. So properties of hydrocarbons. Hydrocarbons are insoluble in water because if you got, for example, uh, methane, same thing again. Methane, same thing again. What happened here? This electronegativity of carbon and hydrogen are quite same. Therefore, there are no delta plus, delta minus, or delta plus, delta minus polarity. Therefore, they are non-polar. Hydrocarbons are non-polar. Carbon hydrogens has same electronegativity. So non-polar substances dissolve in non-polar solutions. Therefore, this is not soluble in water because water is polar. We know now water is polar because it has oxygen is quite electronegative than hydrogen. So therefore this is polar. So the other thing you have to know the formulas for alkanes, alkenes and alkynes. So last slide we talking about saturated, unsaturated uh, hydrocarbon. So from this tree here, the first one, alkane is saturated. That means it has only one single bonds. Alkene got double bond. Alkyne got triple bonds. Those who got double bond and triple bonds are called unsaturated. Alkane got one single bonds, therefore they called alkane. So it is necessary to know ane, ene, ine. Ane means unsaturated. Ane means saturated. Ene mean unsaturated. Ine mean unsaturated. So we move to the other slide. So problems. Find the molecular formula of an alkane with 6 carbon atoms. Okay. What is the basic formula from the last slide for the alkane is CxCnH2n plus 2. Now this one given alkane is 6 carbon. Therefore C6. So H2n plus 2 mean 2 times 6 12. 12 plus 2 14. You got? I think you got it. So C6H14. So that means you just substitute 6 into the n. Therefore 2 times 6 plus 2 14. This is how 14 came. The first question is done. Second question, draw the Lewis structures of ethane and propane. Ethane and propane. So most important thing here, ane. Ane means this is alkane. If it's alkane, there are no double or triple bonds. So ethane. So one thing you have to know, this counting in the organic chemistry, I will write down here now. You note down on your paper. Okay. First one, meth. Second one, eth. Prop. Bute. Pent. Hex. Hept. Oct. None. Deck. So it should be 10 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this counting in the organic chemistry is important. You have to remember these things. So what are the first one? Meth. Meth means 1 carbon. Eth 2 carbons. Prop 3 carbons. Bute 4 carbon. Pent 5 carbon. Hex 6 carbon. Hept 7 carbon. Oct 8 carbon. Non 9 carbon, dec 10 carbon. That's enough for you. So meth, eth, prob, but, pent, hex, hept, oct, non, dec. It is very easy to memorize. So here this 6 means heptane, because it satisfies this equation. So 6 heptane. So now they are asking, give the formula for an alkane with 16 carbon atoms. Okay, it is an alkane. So therefore we know there are no double or triple bonds. So what we can do, they are asking formula for formula. So formula is C16 H34. Are you with me? Because CnH2n plus 2, that means C16 mean 2n mean 32, 32 plus 2, 34. So C16 H34. So this is called, it is go beyond the 10 decade dec. Therefore don't worry about this one naming now with the words. Okay, we go to the other question now. Give the formula for alkane with 52 hydrogen atoms. This time they given hydrogen atoms. So then we know 2n plus 2 equal 52. Then 2n equal 52 minus 2, 50. So n equal 25. So n is what? N is carbon, number of carbon. So they are asking, so the formula is C25H52. This is the answer for this question. Draw the structure of pentane. Draw the structure of pentane. Again, ane. Ane means alkane. Alkane means single bonds. So draw a structure of pentane. Now we count meth, eth, prop, but, pent. So hydrogen in everywhere. We'll be talking about hydrocarbons here. So all things filled up by the hydrocarbon, hydrogens. It's a good habit to put everything over here rather than limiting to the lines. Fill up everything. In this level you need to write hydrogen, but if you go unilevel, there are scenario is different. So now this is the things we have to talk about on this slide. We move to the other slide. So reaction of alkanes. Alkanes has combustion reaction and substitution reaction. Combustion reaction, from the word you know, it is the burning, firing or something. If you want to burn or fire, we need the oxygen. Therefore alkane plus oxygen give carbon dioxide plus water vapor. Okay, so for example we get first the most simplest alkane, CH4, methane. So methane plus oxygen, so this is a gas, oxygen also gas, give you carbon dioxide gas plus H2O vapor, gas. Vapor means gas. So now we have to balance. So one carbon, two hydrogens, therefore 2 here, oxygen then 4, therefore 2 of them here. So this is the combustion reaction of alkanes. All alkanes like this. Not only the alkanes, alkene, they also the same thing. What are the products? The products are carbon dioxide and water. These are the two products. Another reaction is a substitution reaction. From the word substitution, you can see that Substitution means on behalf of something, something adapt. Something taken away as something joined back, another thing. So here you can see we need UV light to proceed this step. What happened with in the first step, this is go further until all carbon has 4 chlorine. So first step, 1 chlorine going to adapt to here. So what happened? So what happened, like here I show you in this way. So CH, 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 Cl, Cl. So what happened? HCl going to separate. Okay, HCl. So HCl we write in the side over here. Now what I have? This chlorine, this chlorine, this chlorine, this chlorine has to connect to here. Okay, so then what happened? C H H H Cl. So one Cl adapt. This this substitution reaction go until tetrachlor CCCl4 carbon tetrachloride formula was generated. So now it is one chlorine. It is again combined with another chlorine and get another chlorine, another chlorine, another chlorine. They all fill up with the, instead of hydrogen, they all fill up with the chlorine. This is called carbon tetrachloride. So we don't talk about much about these details in this stage. Okay, we will come back to it later. Okay, we go to the other slide. Okay, complete the balance and balance equation. Okay, so I told you all hydrocarbon combustion make carbon dioxide plus water. So therefore carbon dioxide gas plus water, H2O gas. Now we have to balance. Two carbons, 6 hydrogens, so 6 hydrogens, oxygen then come in 7. So 7, therefore 7 over 2. Then what we can do, we can multiply everything by 2, because we need to get rid of from this 2 here, this 2 here. So then what happened? I use different color. So we multiply by 2. When you multiply this by 2, it's going to be 7, eh? 7. Suppose we put 7 and here multiply, we have to get 4. Here also 6 is going to be here, 6. So now see, 4 carbons, 12 hydrogens, 14 oxygen, 7 times 2, 14. Okay, write a structure. So we do the other one also. So again the product are same, CO2 gas plus H2O vapor. So carbon 5 of them, hydrogen 12 of them, oxygen 5 times 2, 10 and 16. So therefore 8. So that is how we balance this equation. Now write a structural and chemical equation for substitution reaction between methane and fluorine gas. Okay, methane is methane and fluorine gas. Fluorine means like this. So what happened? HF, 1 HF going over here. So what happened? HF we go on the side, and then other CH H H become 1F. So there's a 1. This process continue further until carbon tetrafluoride is formed. Write a balanced chemical equation for the combustion of alkane that has 6 carbon atoms. They're asking alkane. Okay, we're doing the alkane. So 6 carbon atoms, that means C6H14 according to the CnH2n plus 2 formula for the alkane. Okay, so balanced chemical equation to combustion. So again, this is also gas. Combustion, O2 gas, carbon dioxide gas plus water vapor. Right, clearly this one. Water vapor. Water vapor. So now we balance 6 carbon, oxygen, hydrogen 14, therefore 7. If oxygen system to 12 and 19. Therefore we had to put 19 over 2. 19 over 2. 19 over 2. So now we need to get rid of this 2. Therefore we multiply by 2. 2 here. 2 here, therefore 19 here. 19 here. Therefore here 12. 12. And 7, instead of 7 we put 14. 14. So now it's ready. 12 carbons, oxygen 38, hydrogen 28, all done. Okay, let's move to the other slide. Okay, structural isomers. What are the isomers mean? Isomers mean same molecular formula, but it has different structural formulas. Because of this structure change, their shape change, they have different chemical properties, even though their molecular formula is same. So one thing we can say, butane and methyl propane, they all got same formula. So for example, butane, how many carbons you get? 1 2 3 4, 4 carbons. Hydrogens, how many? 3 6 8 11. So 3 5 7 10 10 H10 for this one. Yeah, for this one again, C, how many C's? 4. How many H? 10. Therefore this is same. This is same, but is the structure is different. These are branched, this one not. This is straight. Therefore their chemical behaviors are different. So we move into other one. Use molecular model kit to form a model of butane. Rearrange your model to form methyl propane. Okay, we have write down butane. Okay, butane, meth eth prop but. Meth eth prop but means 4. Ane mean alkane. No single, no double bond, no triple bond. Therefore we write meth eth prop but. So butane is, we can write like this. Like this. Like this. Then rearrange your model to form methyl propane. Methyl propane. So what? So for example, I show a different color. What happened? this CH3 here join to here, so then it come in C H H H C CH3 H H. Again here CH3 one should be here. CH3. Yeah. So now what happened? This CH3 here in the circle move to the second CH. Move to the up. So then we can get this. Say here in your model to form methyl propane. So meth, eth, prop, methyl here. Therefore, it's called methyl propane. This is called methyl, and meth, eth, prop, propane. So total we call methyl propane. Okay. Form number 10. So number 9 down. Number 10. Form a model of pentane. How many isomers of C5H12 can you form? Okay. Pentane. Pentane means already given here. C5H12. Then ask isomers. How many isomers? So first thing we write down structure formula. C 2, 3, 4, 5. Okay, hydrogens here. Sorry. Right. Okay, this is the first structure we can write. Okay, first isomer. Second isomer, what we can do? We can put this CH3 to here. So I write CH. I write CH3, CH2, C, CH3, CH3, H, H. This is the second one. Okay, third isomer. We can give what happened. Okay, so this one here CH3, CH2, CH2, so one CH3 can go to here, and other one is we can write like this. Okay, like this CH3, C, CH3, CH3, CH3. Here, that's the other one. So 3 isomers for the pentane, for the pentane. There are 3 isomers. Okay, So then we move to other one, and I erase this one. You can note down if you want, hold in the video. So okay, now suggest a reason why. Okay, number 11 first. Draw each isomers for CPA812 that to formulate equation. Okay, we already draw. Number 12. Suggest a reason why the boiling point of methyl propane is lower than that of the butane. Okay, methyl propane means methyl propane, prop, methyl propane is lower than the butane. Butane, prop, but. Okay, lower than that of the butane. One thing, that is the reason why the boiling point of methyl propane is lower than the boiling of butane. Okay, one thing, this one has a methyl butane has higher melting point, boiling point, because its number of carbons are higher than the methyl propane. That's the basic characteristic regarding the boiling point. Another thing, the methyl propane is branched, so that's why these differences are. Okay, we move on to the other slide. Okay. The alkanes and alkenes and reactions. The alkenes make up a family of hydrocarbons that each contains a double bond between two carbon atoms. The alkenes have a general formula CnH2n and are another example of homologous series. Reaction again, combustion reaction, addition reaction. So this time, the last time alkane, we had combustion reaction, we had the combustion reaction, and also we had substitution reaction. But with the alkene, it is addition reaction. This is addition reaction. So combustion reaction also same. Alkene plus oxygen gives carbon dioxide plus water. We come to the example later on. So addition reaction means the reaction additive, never substitute to the other any hydrogen. Hydrogen is still there, but more other things add up to the equation. So we go detail into the next slide. Okay, complete the following chemical reaction. So this is the addition reaction for ethene. So what happened? What are the products? Products, what happened? C bond become one bond. Instead of this one bond going away, it gonna join bromine, but it's still other hydrogens in there. This 4 hydrogen is still 4 hydrogen, but now Br2 come, only different double bond become one bond. With these two bonds, the top bond is called 5 bond. 5 bond more movable. Therefore, Br get added to the molecule. Explain the term unsaturated and unsaturated in relation to the hydrocarbons. Give 2 examples of each. Okay. Like I said before, saturated means only single bonds between carbons. So for example, alkane, saturated is alkane. Example, we can give C2H6, ethane, ethane. And unsaturated mean alkyne, alkene. Alkyne got triple bond. Alkene got double bonds. Examples, alkene example, alkene C2H4, C2H4. Alkene example, alkyne example, we can say C2H2, C2H2. Okay, we move to the other slide. Alkynes are, so now we're talking about the alkynes. Alkynes are hydrocarbons containing one triple bond between two carbon atoms. So this is the ethyne. This is ethyne, also known as acetylene, acetylene. This is propyne. They have triple bonds, Alkynes contain carbon-carbon triple bond. They have the general formula CN2N minus 2. The combustion of ethyl acetylene is used as a oxyacetylene welding. In welding, we use oxyacetylene flame. So what is produce greater energy? So what happens? C2H2 in O2. This gives carbon dioxide gas and H2O with the energy. We move to the other slide. The carbon backbone of some hydrocarbons can form ring. Such compounds are called cyclic hydrocarbons and have the prefix cyclo before their name. So this is normal hexane. This is cyclohexane, like circular hexane. So this is the benzene. This is the cyclic unsaturated compound. We talking here benzene. Benzene have over the period of years different structures. These are four different possible structures, but we are nowadays using this structure. It is the most suitable structure for now. So now naming organic substances. So only few rules I tell you that will help you how to do that. First one, longest chain, carbon chain, longest carbon chain, and then give lowest number to bonds. Bonds can be double, triple, and give lowest number to groups. Attach groups. Okay, that's the three simple thing you have to know. So for example, over here you can see this double bond has to give, according to this, give the lowest number to the bonds. To give the lowest number, you have to count from left hand side. 1 2 3 4, 1 2 3 4, it doesn't matter, then it's coming 6. So this way it can in 2. Therefore we also given the lowest number for methyl. Therefore 2, this one name 5-methyl, 5 over here, methyl, 5-methyl hept. There are 1 meth, eth, prop, but, pent, hex, hept, 2 in 2 into there is a in part, and this one here again we give the 2 here, 2 here, and there are 4 has methyl ethyl, methyl part, ethyl part, therefore methyl ethyl. You just pause the video and look at these 2 examples, and we do more example later.